Alright, we're on lesson 5, our statistic unit, called describing a distribution displayed in a histogram. Our ICANN statement is, I can recognize that the shape of a histogram does not change when relative frequency is used to compare frequency within those histograms. So today we're going to learn what is relative frequency compared to frequency, and we'll notice that it does not change, or it's going to remain the same even when we use these two different types. And remember, our shape is left skewed, right skewed, and symmetric. Those are the shapes that we have of a distribution. Alright, so from a previous lesson, we investigated the head circumferences that boys and girls basketball teams collected. Below is a frequency table of that circumference that we measured. So again, just rereading our histogram, extra small, there's 2 people who would order that. Extra large, there's 4 people who order that. And their sizes for extra large are 590 all the way to 610, not including that 610. Now, here's our next part that we're going to work on today. Brenda indicated that most of the hats were small, medium, or large. To decide if Brenda was correct, the players added a relative frequency column to the table. So that means we're going to add one more column to this table called relative frequency. Relative frequency is the value of the frequency, so value of a frequency divided by our total number of data points. So how many data points do I have? I had 40, so I divide my frequency by that 40. Alright, so what does the 15 in this frequency column represent? Before we start on relative frequency, let's review. What does this 15 in that frequency column represent? And how many hats need to be ordered? Well, this 15 represents 15 medium hats. And how many hats need to be ordered? Well, this question isn't being precise. I don't know if it's referring to this 15 or if it's referring to the total amount. So just to be safe, I'm going to put both answers. 15 medium hats to be ordered, but 40 hats total. Okay, now here's my next part. What percent of the total order are medium-sized hats? Remember, percent is part over whole times 100, and then I add that percent on. So part over whole, that is 15 over 40. I can reduce that to 3/8. When I do 3 divided by 8, I get 37.5% when I multiply it by that 100. So what percent is it? Well, 37.5% of my hats are to be medium. Okay, here's our next part. There are 2 people in my extra small hat size range. The relative frequency is 2 divided by the total number. So 2 divided by 40, well, that's 1 over 20, which when I multiply by, or divide, that's going to be 0.05, and then I multiply that times 100, and I get 5, and I add that percent sign. Okay. Now the interval from 530 to 549 is 8. So I'm going to do 8 divided by 40, which is what? 8 divided by 40 equals 4/20. And then I can see, I can easily get that to 100 by multiplying by 5. So I do the same thing. So that would be 20 over 100, and there's my percent already because I have that 100 in my denominator. So there's 20%. Okay, so here's your job. You're going to fill in our frequency chart. Before we do that, though, let's see if we can answer some of these questions. How do you find the total number of data values? How do I find this number? Well, I added it. I added all of my frequencies to get my total. Now, what will the sum, so sum means what do I get when I add? What will the sum of my relative frequency column be? What will this be right here when I add all of them together? Well, that's going to be 100% or just a 1. Why? Well, this 1 becomes a 100% when I multiply it by 100 and I add that percent. Alright, complete our relative frequency column. Okay, now here's our next part. What is the difference between a frequency table and a relative frequency table? And how are they the same? Well, they're different because my relative frequency table, it has one more row. And not row, I'm sorry, one more column. How are they the same? They both have the same values. They both start out with those same frequency values. They both have the same starting values. Okay, now what do you think we're going to do next? Well, let's check your answers for the relative frequency. And you'll notice when I add all of these up, they will get me that 100% that I was talking about. Okay, now what is the total of my relative frequency column? What is my total going to be in this box right here? Well, that total is going to be that 1 or 100 that we discussed on this page. It's that sum, that total. Okay, what interval has the greatest relative frequency? So we're looking for which one has the greatest or that largest value. Well, you should see that it's going to be the same as just my regular frequency. It's still going to be that 550 to 590, that medium size. And its value is 37.5%. Okay, my next one is what percent of the head circumference is between 530 and 590? Show how you determine your answer. Well, it's asking me between 530 all the way up to 590. Well, hopefully you could figure this out. I'm looking at all these values, so I'm going to add up all of their relative frequencies. When I add them all up, I'm getting that 0.8, and that 0.8 translates to 80%. So 80% of my hats are small, medium, and large. Alright, so now we're taking this information and we are constructing or making a histogram, but instead of using those frequencies that we did on Thursday, we're using relative frequencies. Okay, they notice that the relative frequencies in my table range from close to 0 to 0.4. So look right here. All of my values are close to 0.0. My highest one, though, is close to 0.4. So that's how I'm going to be making this portion right here. That's how I'm going to make that left side. So I'm going to add a scale. I start at 0. I'm going all the way up to that 0.4. And I just need to have a nice even number that I'm counting by. So I'm going to count by 0.05. 0.05, 0.05, 0.05, all the way up to that 0.4. Notice how my intervals on the bottom, they stayed the same. They're staying that same interval that I had in my chart. Alright, now what do you notice about our shape and centers? Here's my relative frequency. Here's my frequency from Thursday. What do you notice about their shape and center? Well, I notice that they're the same. They're both almost symmetric. Now, what is the greatest number that could be on the vertical axis in a relative frequency? So what is the biggest number that I could possibly have on my relative frequency? Not just this example, but ever. What is the largest number that ever could be? Well, it can't be bigger than 1. Why? Because this is percents, and I can't get bigger than 100% which as a decimal is just a 1. So that's my largest it can be. Alright, what is the relative frequency for the large hats? What does this number mean? So I'm going to look back on my chart, and I need to find that large hat one. So large hat is 570 to 590. So let's go find that interval, 570 to 590. And I'm going to look. So that looks like it's right about 24%. If I'm not sure, I can go check my previous frequency table and look right there. So it was close to that 24. So its actual value is 22.5. But now it's asking me, what does that mean? Well, it means that about 24% of the people measured would wear a large hat. So about 25%, or this 24, would be ordering that large hat. The actual number, though, is this 22.5%. Okay, now describe the shape of my relative frequency histogram. So it's still a relative frequency. What shape is it? Well, it's slightly skewed to the right. It has this tail on this right side. It's almost symmetric, but we just have 3 columns here and 2 on the left. So it's just slightly skewed to the right because of that tail. Okay, now we're back to our original question that Brenda asked. Brenda said that most of the hats that needed to be ordered were small, medium, and large. Was she right? What percent of the hats to be ordered is small, medium, or large? Well, my small, medium, and large. Was Brenda right? Yeah, she was right. So now I need to know what percent do I need to order? Well, I'm going to look right here. Are those the values I'm going to look at? No, they're not. These are the values I need to look at. My small value, my medium value, and my large value. So what I do is I add all of those percents up, and it's going to give me that value. So it's that total of 80%. Alright. Now what you're going to do is you're going to complete the relative frequency table. I'll get you started on the first 2. You may use a calculator for this. So a calculator is alright. Remember though, you're finding the part over the whole. So my part is right here. These are my parts. I'm dividing it by my whole. If you don't remember what the whole is, go back into the lesson, recheck. Alright, what is the total number of NBA players? Well, my total number is 29. Not NBA players, I'm sorry, arenas. How did I get 29? Well, I added up all of these values right here. And guess what? This is my whole. There's 29 total arenas, that is my whole. Alright, complete your relative frequency table. So hopefully you got these numbers right here. So now I'm ready to go on to this next problem. What percent of the arena has a seating capacity between 18,500 and 19,999? Well, let's look. It's going to fall into this range. So that's 17.2. And so what is that as a percent? Well, I'm going to take this and I move it 1, 2 for 17 point that. Now, can someone tell me what is wrong? Why does this answer not match this? Well, hopefully you realize that I did not look at my key terms. 18,500. So that's going to go all the way to almost 20,000. So I'm using these 3 rows. So I actually have to add this number 3 times. Or another way to think of it is multiply it by 3. And that's going to give me that 516. And then I take that decimal 1, 2. So make sure, statistics seems really easy, but most of the times because you forgot to look at your question carefully. So 51.6% have this seating capacity because I'm looking from here all the way up to that 19,999. Alright, so here's our completed relative frequency. Now I need to create a histogram. Well, this is what my histogram looks like. I'm using those same intervals. My intervals don't change. And all I'm doing is I'm looking on my relative frequency and just seeing how high that goes. So this is 0.06, so it's going to be above 0.05, below 0.1. You'll notice it falls right in between there. I'm just going along. This one's 0.034, so it's going to be below here. And you'll just see my shape as it comes along. Now, what is my shape of this histogram? Well, I'm going to start out, and I just play connect the dots. Where is that tail? Well, my tail's on the right, so wherever my tail is, that means it's skewed that way. So it's a right skewed. Okay. Lesson summary now. A relative frequency histogram uses the same data as a frequency histogram, but it compares the frequencies for each interval to the total number of items. For example, if the first interval contains 8 out of a total of 32, the relative frequency is 8 over 32, or 1/4, or 0.25. And then we can take that and we convert it to a percent. The only difference between a frequency histogram and a relative frequency histogram is that the vertical axis uses relative frequency instead of frequency. That is the only difference. The only difference is relative frequency instead of frequency. My shapes are the same as long as the intervals are the same. So we'll go back all the way to this problem where we're comparing these two. What do you notice about their shapes? Their shapes are the same. They're the exact same shapes. The only difference is, again, frequency, relative frequency. Everything else about them is the same. Alright, here is your exit ticket. When you're done with your exit ticket, you may go to Dreambox until the lesson is done. When you're done with your exit ticket, go to Dreambox. Alright, good job.